So let's simplify the expression sine cubed of x plus cosine cubed of x. Just to be completely clear, for the purposes of this video, by simplify I mean we want to rewrite this expression without using trigonometric functions with higher order exponents, but multiple angles are allowed. So for example, something like sine of 2x, cosine of 3x, and even sine of x over 2 are allowed, since the angle multiples don't have to be integer. But something like sine squared of x or cosine cubed of x is not allowed since there's an exponent other than 1. I'm also going to say that products of trigonometric functions with different angle multiples are allowed. For example, a term like sine of x times sine of 2x is allowed. This is because we can only rewrite this one as an expression including this kind of term. The idea here is to just simplify the expression as much as possible. So to simplify this expression, we can use the sum of cubes formula. A cubed plus b cubed equals a plus b times parentheses a squared minus ab plus b squared. If we let a equal sine of x and b equal cosine of x, the expression sine cubed of x plus cosine cubed of x is in the form a cubed plus b cubed with the values we set. So this means we can factor the expression into the form a plus b times a squared minus ab plus b squared. And with the given values of a and b, a squared equals sine squared of x, ab equals sine x cosine of x, and b squared equals cosine squared of x. So this means we can factor sine cubed of x plus cosine cubed of x as sine of x plus cosine of x times sine squared of x minus sine x cosine x plus cosine squared of x. And notice how this expression is now in the form a plus b times a squared minus ab plus b squared, where a equals sine of x and b equals cosine of x. So in the second parentheses, there's this sine squared of x plus cosine squared of x, and recall that sine squared of x plus cosine squared of x equals 1, which is the Pythagorean identity. So we can actually rewrite this expression as sine of x plus cosine of x times 1 minus sine x cosine x, and all I've done is replace the sine squared of x plus cosine squared of x with 1. So we can rewrite the sine x cosine x term using the double angle formula for sine. Recall that sine of 2x equals 2 sine x cosine x, so if we divide both sides of the identity by 2 and switch the order of the identity, we end up with sine x cosine x equals 1/2 sine of 2x. So this means we can rewrite the expression as sine x plus cosine x times 1 minus 1/2 sine of 2x. We can also expand this, and if we do, this becomes sine of x minus 1/2 sine of x times sine of 2x plus cosine x minus 1/2 cosine x times sine of 2x. And this expression is now simplified according to the rules we set at the start of this video.